For this problem, we're going to find dy dx evaluated at at the point 1, comma, -1 for the following equation: x plus 2 squared, quantity squared, minus 6 times 2y plus 3 quantity squared equals 3. Okay, so we're going to, first of all, we're going to find our dy dx, and then we'll plug in the point. Okay, so to find dy dx, we're going to use implicit differentiation here. So we're going to ddx both sides. So that would be as such. Okay, so I'm just going to copy that down here, right? So that's for the left side, and then the right side is just going to be a ddx of 3. So we can already tell, well, once I write a proper 3, so we can already tell that the right side here is already going to be a 0. Okay, so I'll scoot that over so we have enough room. Alright, so the first thing is ddx of x plus 2 squared, okay? And then we have minus a ddx of 6 times 2y plus 3 squared. Okay? So on the left side, this left term, we're going to actually use the chain rule, right? Because we have this outside function, which is something raised to the second power. So we'll bring down that 2, make this, keep the inner function the same, right? X plus 2, and then that's raised to the 1 power. And then we'll, according to the chain rule, we have to take the derivative of the inner function. So that'd be ddx of x plus 2. And this will be subtracting ddx. So now we have something with respect to y. So we have to do ddy of 6 times 2y plus 3 squared, and then add on that dy dx, and then that equals 0. Okay? So now what we have is 2 times x plus 2, and then and ddx of x plus 2 is just going to be a 1, so we have a 1 there, and this is subtracting, and so the derivative of 6 times 2y plus 3 to the second, or squared, with respect to y, is going to, we're just going to derive it like normal, right? And then we have that extra term added on there. So if we bring the exponent down in front, we get 6 times 2, so that'd be a 12, times 2y plus 3. The inside stays the same, right? The inside function stays the same. Then we subtract 1 from the exponent, and according to the chain rule, we have to take the derivative with respect to y, in this case, of the inside, so 2y plus 3. So that's going to equal a 0. All right. So now I'm going to rewrite this last line on the next slide. Okay, so we have a 2 times x plus 2, and then we have minus 12 times 2y plus 3 times ddy of 2y plus 3. And then on the right side, oh, and then we have our dy dx, of course, so we cannot forget, and then equals 0. Okay, so let's figure out what this is. So 2 times x plus 2 minus a 12 times 2y plus 3. And then, so if we take the first derivative of this with respect to y, we get a 2 out. And then we have our dy dx equals 0. Okay, so we've simplified as much as we can, taking the derivatives, and now we'll just get dy dx by itself. So to do so, I'm going to add all of this over to the other side. So I'm going to combine the 12 and the 2, and those multiply to get 24. Then we get 2y plus 3 dy dx. So if we add that over to the right side, we have to do the same thing there. So 2y plus 3 dy dx. Okay, so on the left side, all that's left there is 2 times x plus 2, right? And then on the right side, we have a positive 24 times 2y plus 3 times dy dx. So now all we have to do is divide on both sides by this 24 times 2y plus 3, divide on the left side by 24 times 2y plus 3. And we're finally going to get that dy dx, so dy dx, I'll just put it in at the bottom here, is going to become, we can simplify that, to an x plus 2, and then over a 12 times 2y plus a 3. Okay? So this is our dy dx, and now this is not the final step, because the question asks us to evaluate this at the point 1, comma, -1. Alright, so we'll finish this up on the next slide. So we have the dy dx itself is equal to x plus 2 over 12 times 2y plus 3, okay? And we're going to plug in a 1 and a -1. So x is equal to 1 and y is equal to -1. So dy dx, evaluated at the point 1, comma, -1, is going to be equal to So if we plug in a 1 up there, positive 1 plus 2 over 12 times 2 times a negative 1 plus a 3 on the bottom. Okay, so this is going to turn out to be a 3 over 12 times negative 2 plus 3, so that's just a 1. So overall, we're going to get a positive 1 over 4 as our answer. Okay, so that does it for our practice problems video for implicit differentiation. I hope that helped, and happy studying! But I'll find one soon in time.